welcome to my channel. Let's learn the algorithm together. Today we will take a look at the 162 find peak element. So what is a peak element means? A peak element is an element that is strictly greater than its neighbors. So now this problem will be given the integer array numbers and then find the peak elements and return its index. So if the array contains multiple peaks, then just return the index to any of these peaks. And you may imagine that the numbers -1 or numbers n is always a negative infinite number. So in other words, an element is always considered to be strictly greater than a neighbor that is outside the array. And we must write an algorithm that runs in O log n time. Now here's two examples. We will take a look at the second one. Probably it's more complicated. So now we will have like 1, 2, 1, 3, 5, 6, 4, right? And now we need to search for its peaks. And if we visualize it, it will be like, probably this is the 1, and then this will be 2, and then 1. Let me write it like this. And the next is 3. Let's redo it again, like 1, 2, 1, 3, 5, 6, and then 4 again. So it will look like this. And which is the peak? The number 6 is, the fifth number, the number 6 will be the peak because it's greater than its neighbors. And also 2 is the peak because it's also greater than its neighbors. And now we need to find like which is the, we just need to return one of them, no matter return like 1 or 5th, that will be okay. So now how we find this peak? And also another situation we talk about is like for the first node and the last numbers, it will always greater than its neighbors. Not neighbors, the numbers out of the range. For example, like here, it will always greater than it, or here, it will also greater than it. So what if the numbers are look like this? They are all in our ascending numbers, going like this. Numbers, 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 numbers. So which is the peak? We'll say the peak is the last one. Why? Because its neighbors is always greater than its neighbors, and its neighbors is the right neighbors will always be the negative infinite. And if in also the descending orders, also this will be the peak because it always greater than its neighbors, and its left neighbors will be negative infinite. So here is the situations we will have for this problem. And now let's go back, like how we find the peak. And we just like also continue to have something like this. And now when we are searching for something, we usually use a technique is called binary search. And how binary search work? If we are searching for a target, something like search for a target number, and usually we will just first sort it the rate, right? And then we start to use a left pointer and a right pointer to help us search in this area, in this range. And then we also need a middle pointer. Middle pointer always equals to like the left plus right and divided by 2. We get a middle pointer. Once we find the target number is greater than the middle number, and then we go to the right side. But if the target number is less than the middle number, we will go to the right side. So binary search will just every time help us to make a decision like we go left or go right. Could we apply this in this problem? Now that's what I'm thinking now. And probably we could. Why? For example, we are also having the left pointer here and also the right pointer here. And then we will calculate, also get the middle numbers. And how we decided to go right or left now, right? So for example, like if you already get the middle numbers here's the middle number. And I'm thinking that we also think about use the middle plus 1 numbers. So compare these numbers. If it like this, it means that the peak will be here, not here. Right. It will only go to the right side. So as I said, if the number on mid plus 1 is greater than like number on middle, it means that we need to go right to search the peak. Right. And what if like the middle pointer is like this? If the middle pointer is greater than the next one, it means that the peak will be here, right? It will possible be here. Possible, not have to, just possible. Of course, as this problem, we can see that the middle, well, less than the middle one, plus 1. So we say peak here, but also the left side we have peak. But this problem saying that we can only just find one peak, no matter it's on the right side or the left side. So when we are comparing the mid plus 1, well, even though we go to the right side, we definitely will find at least one, right? If the one is not here, but at least it will be here at the middle plus 1. So other cases is like if the numbers on the right on the other side is less or equal than, we will definitely say we will go to the left side to search the peak. But here is a problem, like how we decided it is like greater or greater equal, right? So now when we are searching for a target or something, if we are not like using the middle point to find out something, and usually we will like use the left pointer to help us. For example, like if you decided to go to the right side, right? If we go to the right side, it means that our left pointer will be moved to here, left pointer will be equals to mid plus 1. And because we are considered the left could be the peak. And if we are thinking that like here, this middle pointer could be the peak, we'll just move the right pointer equals to mid. So once the left equals to mid, they meet together at some point. So now we'll just return the left as our peak. Right, so when we are narrowed down, and when we stop is while left equals to right. So once the left still smaller than right, we'll continue to decide to go left or right. But when they're meet, it means that we exactly find that numbers could be the peak. And now, since we are like narrowed down into the last one, so probably we already found that one is the peak, we can just return the left pointer. And this is how we use binary search to narrow down to only have one element left. And the only one element left will be the answer for us, like the one we are looking for. And that's how we solve this kind of problem. And let's go through this example. Like we are now having the left pointer here. Probably we can just say left and right. And where's the middle pointer? So the middle pointer will be 3. And then we find that the middle and the middle plus 1, when they compare, is going up. So then we move the left pointer to here. And then we calculate it. Like 3 plus 6 equals to 9, and divided by 2 will be 4. So the middle pointer will be here, and we compare these two, remember, and find it's still ascending. So then we move the left pointer to here, and then we recalculate, like get middle pointers here, and now we find that like the middle compared to middle plus 1, the order will be like decreasing. So now we move the right pointer to here. Now the left pointer and the right pointer, they meet together, which means we already found the peak. So we just stop it. And because when they are meet, and now we just return the left pointer, it means that we already found the peak. So this is the regular example. And how about going through ascending example, like this 1, 2, 3, and 4, and 5. Something like that, and also have left and right pointer. And now the middle pointer will be 2 here, and we can find that it's going ascending again, which means the left will move to here, and then we recalculate, get the middle pointer will be here again. So it means that we compare the middle with the middle plus 1 is ascending order. So the left pointer will move to here. And now the middle pointer and the right pointer already meets. It means that we can return our left pointer now. So it stops and just return left. So this is another case, and all of them are already passed. And just remember, if you want to search for the left side or right side to narrow down, only have one element, we'll just stop it when the left pointer and middle pointer meet. But how we move the pointer is the left pointer will always move to the middle plus one side, and right pointer move to the middle one. So now this is how we solve the problem. And what is the time complexity? Because we are using like binary search, so the time complexity will be O log n. N means the numbers of these elements in the array. And how about a space? We doesn't use any extra data structure, just 2 pointers, so we can assume that it's just constant time. So this is how the time and space complexity. Now let's move to the coding part. And let's say here, make it larger. First, we will initialize the left pointer at 0 and the right pointer equals to the length minus 1. And then while the left pointer is less than the right pointer, we can start to deciding which part we are searching for. And now we are saying if the numbers, we will calculate the middle pointer. The middle equals to, we use left plus right minus left and then divided by 2. Why we're doing that is we just ensure that when we are doing left plus right, the integer sum will not be overflow. So we are decided to use left, right minus left first, and after divided by 2, we add it back left. They will have exactly the same numbers. And after that, we compare the numbers middle with the middle plus 1. So once it's in an ascending number, we go to the left side, like middle plus 1. Else, we will move the right pointer to the middle pointer. And after that, we just return the left pointer. So that's it. And I'll just run it. Cool. And submit it to see. Yeah, all the test cases passed out. So this is how we are solving this kind of problem. Even though we are searching for a pig, but we can convert it to the idea like we are always decided we going to left or right, and binary search will help us to work on such kind of problem. And that's it. So if you think this video helps you, please give me a thumbs up, and that would be great encouragement for me. Thanks for watching. See you at next video. Bye.